So this area is for the spray mist. So you have a spray mist system, you also have a coolant system. So the coolant system being the water and the oil in here, and then a spray mist system which is on the back end of the machine, which gives you a spray over the top for a lubrication as opposed to the oil and water. To make sure that isn't conflicting, none of these bars that go either side of the blade are touching the blade, nor is the actual nozzle on the front of this block, because that lubricates the teeth, and then these bars lubricate the side of the blade. On the back end, the large tank is for the two bars that run the actual faces of both sides, left and right of the blade. And you can regulate those, but they're set, you don't need to touch them, just leave them as is. Every time that you change a profile, and the chances are they're going to be pretty similar in regards to how far the vise opens. You should have the same opening on the movable part of the vise. The reason I say that is because if you open this like that, and the opening size increases, the vise on both sides comes out and then moves across your cutting point. The last thing you want to do is cut through your vise. Okay, so you can adjust the ways in which these move for the different types of material, i.e. the widths of the material. So in effect, when opening, that will be in a safe area because the blade will literally come straight through there and also straight through there. You want to get the back ones as close to the blade as possible, so what we do is very quickly, if I just rotate that and run it down, the position where it is now, when you lower that blade, you need to make sure this is the maximum point it's going to go to the left, at 45. The maximum point to the right obviously would be that 45 angle right the way through there. So you make sure that the back vices, once they're fixed in position, you won't have to move the back vices again. You just want to get them as close to that face there to there as possible. And then when it comes to these, depending on the thickness or the width of the material, if it's there, you're going to end up cutting straight. If you look down there through the side of the blade, you'll end up cutting through it. So you obviously have to adjust these ones here for the width of the material. It's ideal to get the back vices as close to the blade on the angles as possible. The reason being is because it's rotating this way, you get a reduced burr, providing that the clamps are as close to the blade. Close to the gap, the better the cut, because you've got more clamping force as close to the blade as possible, especially with that material. If you had the vices too far away, you start adjusting them away from the cut, because it's so thin, the only clamping area that you're going to have is that back, this one here. If you run it to here, you've got a blade doing this, it's going to start to make this flat. You clamp there and you cut through there. This is just going to be doing this. So the closer you get it to, there's less chance that this is going to start to vibrate and flat because it's so thin. Okay, so we've got this vise set. When it comes to the 50-50, if I start opening that to try and gain 50-50, this is going to touch. So we've got to start to adjust that to those, to the material that we're going to cut today. Okay. Now that back vice position is okay because it's really close to that. The maximum angle you can go on there is 45 degrees to the right. So providing you've got that as a full extension right the way around, which you're only going to cut in 45 left, 45 right to make the picture frame. So that position is okay for that back vice. Now we can adjust these ones. And you need to adjust these two vices when they're open. So you need to set the vices when the vices are open to the blade, not when they're closed. Okay? Remember, when you do change these profiles, that you check these vices are clear of this area and this area when the vices are open. At the start of every morning, when you switch the machine on, this is what you'll see. So you've got a carriage access point and then you've got a rotation point. What these two do is they zero the carriage. So on the carriage, you'll see this little screw here with a micro switch on the carriage. When that meets that position, it will hit that and then back off by about 5 mil. So that zeroes the carriage, because before, when I wired this up, it was showing that I was 520 millimeters at that position. So now I've zeroed the carriage, it knows exactly its position at 500 in that position as opposed to down there. The same for the rotation, there's a switch at the top, so this will access home to run round to -45. It will hit -45, back off and gain probably 44.2, something like that. So we'll do the process. We can do the carriage first. The reason it's running so slow is because it doesn't want to run at pace and hit that switch. Yeah. Because what it's sort of surmising is that it doesn't know what position the carriage is in. So until it finds that position, then the speed will increase when it knows, okay, we're in a safe place to start moving. And if you look down here, when it touches that switch, this switch to that bolt, it will do this. Okay, that's the carriage done. Going back into rotation, when you hit the start button of rotation, it will slowly rotate round to -45 and then back off and end up at 44 point whatever it may be. Just to show you what they do independently. Now it knows exactly where it is. We can run the carriage to whatever length it is, but in programming for automatic and the automatic environment, it'll know where it is and it'll do what it needs to do for where the material is. So what you can do is straight away press the start button, it will do the carriage and it will also do the head at the same time. Okay. Once it completes that cycle, it returns to this page. When you see this page first thing in the morning, make sure that there's nothing on the bed of the machine, there's no material in the bed of the machine, it's not halfway through a cut of any kind, it's completely clear. You know that the head is going to go up and then rotate to 45, making sure there's no obstructions on the machine. If there is, you've got sort of foul ups and everything else. Same for the carriage, there's nothing on the carriage like bits of steel, making sure that that area there never has any material on there that shouldn't be on there. It shouldn't be on the machine at all. The only thing that you'll find on there is the coolant and the swarf. That's it. This page is your main menu for all of what this machine does. So you have a manual environment to use the machine for 1, 2, 3 cuts, etc., etc. We have an automatic programming environment where you're going to run this sort of profile in the lengths that you want to carry out, depending on what lengths they are. So starting with a manual environment, you've got carriage left, carriage right, obviously using the arrows to give you directional. You've got head or the blade down, blade up. So if I just, with the regulator, head down, up, carriage. Okay. Vices, so these vices will run the arrow vice. This is closed and open, closed, open, closed, open. Arrow is carriage, it's the movable. And then number 1 is the first one fixed, and number 2 is the second fixed. Clamp, clamp, clamp. Making sure, once again, it's so important that when you set the vices that they are always open. Make sure, even just close them and then open them again to double check that they are open before setting them, because in the process of the automatic page, the vice will be opening and closing. When the material is finished cutting, the right vice will open. If it opens and it's halfway through the return of the head, you don't want for the vice to come back and hit the blade. So it's got to be clear. You have a blade speed RPM change, so you can change in motion. You can also just input 55 RPM. Rotation, if you're doing it in a manual environment, so if I wanted to bring that back to 0, I just press that and I go to, it will rotate to 0. and it'll just go back to go to. If this stop button remains, wait for it before the next command, because it's obviously just finding there's a magnetic strip along the top of an encoder, and that just guarantees that it's going to find 0. As you can see, real position is 0. It's running a 0, real position 0. So it's actually, it knows that it's in that 0 position because we've done that access homing at the start to find that 0 position. You can turn off and on the hydraulic tank. You have a choice of water and spray. So the spray being the one at the back, which is the nozzles on the front here, or the water, or you can run both consecutively. No point. You know, personally what I would do is I would run that with the water all the time. Because the more flood that you get on the cut, especially with a profile and it's finding its way through all of those different things, the best to have as much water on there as possible. You can run it in spray, but I just prefer, me personally, I prefer the flood. I prefer flood. Tank start, machine is ready. We've got 50 millimeters of material, so we can run a procedure like that. So what you would do is you put that into the machine. In a manual environment, not automatic, you don't need to press anything in an automatic environment. You just press the start button, it will clamp and open and do everything it's supposed to do. In a manual environment, you have to clamp it yourself. Do everything yourself. And then it's a means of pressing the start button. Prior to pressing the start button on any start of an automatic cycle or a manual cycle, make sure that that is at 0. The reason being is because if you was adjusting to control the vices and the position of the vices moving in to make sure that you're not gonna, hit the material, if you set that all the way around to 10 and you press start, it's gonna go whack. So we don't want that. So run it back to 0. On the first cut in an automatic cycle, you can judge your first cut. Oh, that sounds good. Then you're done. And then throughout the whole cycle or the whole page or until the material runs out, that speed will remain exactly the same. In a manual environment, obviously once you've got the machine running and it's starting to spin and everything else, then you can start to run the descent. But always look at that before pressing the start button at all times, because you don't know if there's more than just yourself running it or you're running it or whoever. If you've got more than one person running the machine, they may have just gone, they were setting the machine, oh, I've got to go and do that over there. Always look at that first, set it to 0 before you press that start button, and then it just covers your blades, your material and everything else. If there's multiple people using the machine, just have a cursory glance over the machine and make sure that someone hasn't opened the vise to get a bit of material out, or, you know what I mean? We don't want any problems. You've got 3 gauges here, so these are pressure regulation. So the first one here, meaning with the arrows, is similar to this abbreviation here, so this is for the carriage. This will increase and decrease the pressure that is clamping on the carriage. This one here is for the first vice, and this one here, so it's in 1, 2, 3. You have an emergency stop, obviously for emergencies. You have a cable insert for an Ethernet cable, but that's something else to discuss at a later date. You also have a USB, which has similar sort of properties to this one here. Another thing. There's 2 filters on the side of here. There's a fan and there's an ingress filter. Because it's such a small space in there, it keeps the panel on the card and everything that's working with this panel nice and cool. To make sure that these areas are kept, relatively clean.
How often would you clean that, Mark?
I would look at that every 2 weeks.
Yeah, it maybe even
in here where it's quite dusty.
When it's really dusty, you'll see the first that it'll be fine for the first 2 weeks. If it's really, really dusty, after the first 2 weeks, it'll be fine. There's not really anything else that you're going to need to know other than the main isolator on here. In the front, you saw where we was pouring the coolant. There is an overflow hole on the other side, so if you get too much in, you find it's going across the road because you put too much in. You can pour the coolant into the top of the machine, and it will find its way down through the machine, into the tank. The first tank at the top is to catch your swarf. The second tank is to, obviously, the top tank is to filter the water with your swarf. So at the back of that one, you'll see a gauze.
Oh, yeah. No.
That will allow the coolant to drop into the secondary tank underneath. You can empty this tank with the swarf into your bin outside or whatever, and then you fill it up from there. You can pour it into there, but be aware that if you do overfill it, make sure to see how much coolant you've got within that bottom one. Making sure that every time that these doors are closed, making sure that everything is closed at all times. Never ever do that, like we're doing. I'm just doing that for the process of the training. But once you can see everything from here anyway. There's no reason for you to be doing this. Keep the doors closed, keep the interlocks closed, making sure that all the doors and everything and all the guarding is in situ. You've got handles here, which you're adjusting to. But once you've put them back in, you know that you've set that machine. It's just another point for yourself to go, okay, I've done that one. Let's not leave the handle out. Okay, if I put that back in, I know that I've done that bit. To the second handle, you adjust it, you make sure it's not going to hit, you close it up, and it's clear. On the secondary side, or the exit side of this machine, you have, inside here, if you come around this side, you have a slope or a drop off. That's for all the offcuts that you're going to get when you do your picture frame. So if they don't drop through the gap, because they may not, they'll be pushed through off the edge and fall into a bucket. The drop off is for the very small inserts that you're going to get. If you're just going to do a trim cut, it will just drop down, slide in there, and come away.
How big's that hole, Mark? How wide is it? Where is it?
It's the bit that's there, so...
Yeah,
So it'll go down there and then drop into a bin. Not all the time, but most of the time. Blade rotation. Obviously it's in that angle just for this testing purpose. When I stop that, doing this. Blade rotation being the way in the rotation in which it's cutting. See, that's... So if I... As soon as I press that start button, it will clamp everything. But like I say, manually run the process. When you're setting these clamps, you need to literally run it up to the profile. Just enough for it to close. Give it enough, because if you don't give it enough, it won't allow for the air to go into the cylinder and give you clamp pressure. You can see that there, it will start to change. You won't always see it from that side. But the guarding, it's a necessity that the guarding is on all the time. If that blade shatters in any way, at least you've got it in within a cover, or it's enclosed. Just, keep it away from you. This is how you're taking off and put it on the guard. I've got two there. There's one already in the top there. You don't need to take that right out. That just slides in the elongated slot there. Like that. Place this bottom one in. And then there's this one. It runs under here. When you're changing the blade, or when you're changing, let's say, the diameter of the blade determines how far the blade comes down through the cut. So let's say you've got this blade on there, it will come down to this point. If you reduce the diameter of the blade, and when you get them resharpened, it will reduce. It will go like that. So the overall circumference will reduce. What will happen is the reduction within the diameter of the blade will not give you the same depth of cut. So you can adjust the point down position of this machine by going into this page first, tapping start and stop together, which will give you your high point, low point and safety point. By lowering the blade, and I tend to run this at your maximum angle. So
Why do you hide it in there like that, Mark? That you're having
because
to...
you don't need to change it all the time. Once the blade is on there, you can run a series of cuts with one blade. Now you may get 1,000 cuts out of a blade. You only need to do it if you're changing the diameter.
Yeah.
Sometimes people run this machine and they'll have blades that have been resharpened 100 times.
So there's a lot of guys that don't sharpen the blade, they'll buy a new blade.
Buy a new blade, they won't need to do anything. So let's just run that at 45. The way that I adjust the bottom point to all material is whatever material is in the machine is by running that into there, okay, lowering the blade in the manual environment. Let's go back. If you look down that tunnel there, you can see whether the blade is going to clear the bottom of the material at that point. So if you look at that, you're about 3 mil-ish away.
Yeah.
Once you've got that into position, you tap low point. So now we can raise the machine up. Just want to check one more thing. Okay, so in a manual environment, we're going to do a straight cut on this material. 0 angle, making sure the blade is in the up position. Straight cut, blade down, blade up. In a manual environment, you can just press the start button and the blade will come down. With an automatic cycle, you would run the blade just above the material. So you would lower the blade, just above the material. Once you've got it above the material, when the blade goes up and it's changing its angles, it will only return to that position. Otherwise, the head will go all the way up and it will take all that time to come back down again. So wherever you press the start button and the position of the head, that's where it's going to return back to. Unless it's going into a safety point where it will rotate freely away from any of the, the issues. Hence why it's important that these vices are set correctly, because if it's rotating on a small profile, let's say you had 10 mil you're cutting in there, it'll only go up so far and it's rotating between the vices. If it's rotating those axes through the vices, those vices need to be clear. Lower it down to the bottom point, back to 0. Once you've got it back to 0, you can now press the start button. But let's do the normal thing. Make sure everything's clamped. Now we've got everything closed, you can see the pressure. There's nothing else that you need to do on there. That starts the hydraulic tank on and off, but when you press the start button it will kick in anyway. Now we're good to go. Now we can press the start button. What do we need to check before we press the start button? That one. All the vices are clear. We're going to do a normal straight cut now. We know the rotation is correct. The coolant's flowing on top of the material. First couple of cuts on the new blade, you want to go easy because you want to vet that blade in, make sure that the edge is lost. When they regrind them, it does leave a slight burr on the blade, so you want to clear that burr, and then once you go into the cut, it'll run nice and smooth. Because you're clamping both sides of the material, that also reduces the burr on the sides as well, because it's cutting the burr away as opposed to something that's flapping and just idle.
Yeah.
That's why it tends to bend over.
Yeah.
But you get left with a minimal burr at the bottom. But that's a nice cut. Only because it's slow. If you start to speed that up, a lot of people won't afford to run it that slow. It's mill finish. You just got to dial the speed in. Like that blade is not necessarily ideal for that at high volume. But if you dial it in, you can listen to it, you can hear the actual noise, and then you increase and decrease and you play with it. But so when you go into, now you're going into angle cuts. This is just general. You can run an angle cut in a semi-automatic or manual environment. You just rotate the head and do everything you need to do. The only thing you can change when it's in cycle on this program and the automatic program is the blade speed. You can't change anything else. There's no reason for you to change anything else. The machine should be set. Okay. So inside the carriage here, you see that red dot? So the red dot is the end of bar.
Yeah.
Let's say you have a profile that's in this machine and it's feeding the material. When the machine clamps, it'll always be clamped at some point within an automatic cycle. When this side clamps and the carriage returns to grab the material again to feed, if by any chance, so I'm going to simulate that this is moving backwards, right? So the carriage is moving backwards, it's moving backwards, and suddenly it sees that beam, it makes the beam, it will stop, it will clamp that material, and then it'll optimise whatever's left in the cutting list with the amount of material that's in there.
Yeah.
Okay.
Yeah.
It won't continue to run.
Yeah.
It will just continue to run with
What's left?
what material is left. Within a cycle, it will come up and prompt you, press F1 to, load a new bar.
Yeah.
So you take out the remaining, so you push it through, or use the bar that you're feeding through, or the profile you're feeding through. Push it through, and you push the second bar underneath the blade. The cut will always start with a -45, so it'll always cut this way. But always make sure that the piece that you put under the machine is always clamped this side. Don't just...
Yeah.
It's got to be clamped this side. The smaller you leave that first cut, the more chance it's going to drop in there and get jammed. So you need to give it enough waste under the blade, on this machine especially, halfway through this vise. Do you know what I mean?
Yeah.
But at least you've got enough material on the bed, being clamped, and it will be able to push it through and off the other end.
Yeah.
You leave it too small, it might just drop in, especially if it's, running that angle there, you leave a little bit, it sits on the top of there, it goes to push through, and suddenly you've got to build up a material to go through the ceiling, So we're going to do 45 left, 45 right. In an automatic program, the bar is going to recognise that it's at the end of the bar, but we're going to tell it it's got a 2 metre length. Okay, it doesn't matter that you've told it's got a 2 metre length, because it will recognise it anyway and go, right, we need to start changing what we're going to cut. We're probably not going to get many cuts out of this bar, but when we load the next bar, it will continue with the same program. Okay. So this is the automatic programming. It looks a bit daunting initially, but it's really quite easy. Coolant on or off, which is the same process as the one before. You can see on, off. Blade speed, we were running previously, if you look at this one, we were running at 65, so let's run at 65. As easy as that. This part is important. If your reversibility is on. If your reversibility is on and you're nesting, meaning to say that with reversibility of the pieces, meaning you've got, you just run it. See that? You can do it on this, you can't do it on that profile. Okay, so reversibility will be turned off. But it's important that if you are running this, let's say you decide to cut this, you run it with reversibility on, because it's a 50 by 50, There's no profile element to it. You can nest it and reduce your waste. So we'll do that. Let's just run that program there. Reversibility on, minimum waste. The bar is 50 mil. The bar length is 2 meter, although it's not, but we're going to put 2 meter. Minimum waste, 50 bar, coolant on, 65 blade speed. Recycle button. Okay. Coolant mode. Water. 65. Coolant on. That's the only things you can change on there other than the height of the blade. The material is under the blade. 0. Now we're going to run blade up and down just above the material because that's where it's going to go before it rotates and starts to do all of its thing. So if you look at the gap under there, you can get it a little bit closer, but initially with the hydraulics you will get a slight drop. It will go boom. So you want to give it enough. Back to 0. Always back to 0. That's what we need to cut. The magnifying glass is optimizing that part. We're going to do it in minus 45 plus 45. So we're just going to get a nesting effect like this now. So we're running a 400 length.